Okay, so this last required learning target for the year. This is what I identified. One of the last things I had identified that I wanted you to do is you've done all this work with quadratic equations, factoring, and multiplying and all that. So, what does it mean to graph them, and what does it mean to how many solutions? I can look at a graph and tell how many solutions I have. Well, there's three things that can happen with these things. It can touch the x-axis once. In that case, there's only one solution. It can cross the x-axis twice, and that means there's two solutions. Or it could never touch the x-axis. It comes down, turns around, and heads back up to infinity. Or it could be, all of these could be upside down in the same situation. So then what we call these, there's no real, maybe I better write that just so that you see that. This, if it happens like this, we say there's no real solutions. With that said, there could be some imaginary solutions or complex solutions. When I said that last year, they all groaned. You mean there's imaginary numbers too? I said, oh yeah. We won't see them. You won't see them in this course. You'll see them in Algebra 2. We'll look at them a little bit in pre-calc if you go to pre-calc. And Calculus 1, you won't see them. Engineers start seeing them when they start studying all the forces on objects. I've never studied them beyond what we see in Algebra 2, so I'm kind of at a loss. It fills in theory is what it is. In case you're interested, the theory is there's a fundamental theorem of algebra, we call it, and if you take a look at the biggest exponent in an equation, that's how many solutions there's supposed to be. So if I have x plus 3, so if I have y equals x plus 3, that tells me there's only going to be one solution. Of course, that makes sense because that's a linear function, and it crosses the y-axis at 3, and there's a slope of 1. So that makes sense that somewhere it's going to go back and cross the x-axis. If the degree is 2, that tells me there's two solutions. They might be imaginary, they might not be. If the degree is 3, that tells me there could be 3, 4 could be 4, and so on and so forth. Now we're getting way beyond this course, and I don't want to go there. But it exists, and the reason we have we have to have those imaginary numbers to fill in the theory. I've been told that when they're designing airfoils, airplane wings, that some of those equations they use to model those have solutions that can be imaginary numbers, complex numbers. And when you flush a toilet, you get that circular flow, that Coriolis effect. Well, the stresses that flow puts on pipes also have equations that can be models that there's imaginary solutions to, complex solutions. So at least that's what I've been told. So anyways, let's go on and get you some practice and eyeballing these three kinds of solutions, and that's all you got to do. So I'm looking at this equation. I see that it opens down. I also see that it crosses the x-axis twice. The graph's a little weird. Here's the y-axis, here's the x-axis. I see it crosses twice, so that tells me there's two real solutions, two real roots, we might call it. Two real zeros, we might call it. The reason we call them zeros is because isn't the coordinates at that point -2, 0? The y is equal to 0, and -6, 0. So that's why we say there's two zeros, there's two solutions. We might even call them two roots. I'm not quite sure where the term roots came from. It's got something to do with the theory. Old stuff. So that has two solutions. You could skip over what I'm going to do next here for this slide if you want. What could we find them? One thing I see that's really nice about this graph is it looks like it crosses at integer values, -6 and at -2. You folks have enough math behind you now at this point where you could solve that. And just maybe as a review, I'll do that for you, and you can watch this part if you want. This is beyond the learning target, but it's a review of what you've done already. So let me come back here and delete some of this stuff, and we'll do a little math with it. So I know when I'm solving a quadratic equation, I have to set it equal to 0, right? And that's what we're trying to find. We're trying to find the zeros. We're trying to find the roots. So I'm going to do that. I'm going to say y equals 0, and now I want to find what x values make that. I see a greatest common factor of -1. Each of those can be changed to be a positive. So we want to do that because that makes the work a heck of a lot easier. So x squared plus 8x plus 12 equals 0. And then we can divide. You saw this in our factoring, solving quadratic equations with factoring lesson. I can divide both sides by that -1 to get that right out of there. I don't even want to have to think about it, because it's not going to change the zeros. It's just flipping the equation upside down. And then, you can think about the factoring. Let's see, how good are you at factoring? I know A times C is 12. What are the factors of 12 that will add to be 8? Well, I think that's 6 and 2, isn't it? So I think some of you are here. So I'm going to write x squared here. I'm going to write 12 here. I'll put 6x here. I'll put 2x here. So I can factor out an x. I can factor out a 6. I can factor out an x. I can factor out a 2. So x plus 6 times x minus 2 has to equal 0. And then we use that zero product property. Well, x has to be -6, because if x is -6, the whole mess is 0. And x equals, oh, sorry, this should be positive. I wrote that as positive. X equals -2. That's also 0. And, of course, look where the zeros are on the graph. You see those? So that's where those came from. So that part you know. So for this graph, here's the x-axis, here's the y-axis. I see it crosses the y-axis as a 7, but that's not what we're looking for. We're looking for the x. We're looking for the zeros, the roots. Well, here's a situation where it doesn't cross the x-axis. It heads to infinity this way. It heads to infinity this way, and it has a turning point right there. So there's no real solutions here. And for this course, you don't have to find them. So here's a quadratic equation. I'm seeing it crosses the x-axis twice, and they're also at integer values. So you have enough math that you know how to solve it. If you want, you can try that. So let me finish the question here. There's 2 real solutions here. 2 real roots. And they're integers, so that's nice. This one, again, what are you seeing? Here's the x-axis. Here's the y-axis. This heads up, turns around right there down at when y is -4 and heads back down. So what do you think? How many solutions? I hope you said no real solutions, because it never crosses this x-axis up here, right? Now here's one that's a little different. And what I'm seeing is it does come up, it crosses the x-axis there, it crosses the x-axis there. But those aren't nice integer answers. I suspect they're going to be kind of miserable decimal kind of versions. But still, there's 2 real solutions. It's just that they aren't nice integer values, which that happens. In fact, most of the solutions aren't integer values. But if you choose to do the optional work after this week's work, you're going to learn how to deal with that. I encourage you to do that too. Last year's class got through this. I'm hoping you guys can at least do the same. So what do you think? What are you seeing? I hope you say, oh, yeah, there's going to be 2 real solutions. They just aren't nice numbers. So 2 reals. What do you see? I hope you said 2 reals again. Again, they just aren't nice numbers. And do you get the idea here? Let's see what here's another no solution, or another 1 solution. So here's a graph. You see it only hits the x-axis once, so that means there's only going to be 1 solution. It's real, because it exists. maybe what we should do is try to deal with this. This equals 0. Be nice to get rid of the negative, so I'm going to factor out a negative and divide both sides of that equation by that negative. That way we don't have to worry about it. Notice I changed all those signs. Don't just get rid of one of the negatives. You're going to change all those signs. So how does that factor? Well, I'm hoping you got enough work under your belt here. What multiplies to give me, let's see, 1 times 25 is 25. What are the factors of 25 that add to 10? Well, I hope you see 5 and 5, right? So x plus 5 times x plus 5 equals 0. So there's only one solution here, -5, because they both have it. Some of you might be thinking, well, I thought you just said, Mr. LeMay, that there's supposed to be 2 solutions, and we're only seeing 1. Well, what you're going to learn about in pre-calc is that this has multiplicity 2, we call it. Don't we just make things up as we go? Multiplicity 2, because it's got to count twice. It's got to fit the theory. Okay, so that's really what happens here, and it's kind of cool when you're doing the factoring to see there's only one solution, and that's how it links to the graph. This is probably a long enough video. I'm going to have some kind of activity. I haven't come up with it yet. It might be some kind of card sort. I'll see what I can do, just for a grade for this. Give a yell if you need help.